Welcome to this video for National 5 Physics looking at background radiation. What are we learning about? Well, we're learning what background radiation is and the different sources of background radiation, and also to describe an experiment that could be taken out to measure the background radiation. So what is background radiation? Well, nuclear radiation is all around us. It's happening right at the moment where you are. Now you can't see nuclear radiation, but it's there. You can sometimes see the effects it's having, but often you cannot. But there's lots of naturally occurring radioactivity. Some of this comes from natural sources, some of this comes from man-made sources. We can measure the background radiation using our Geiger-Müller tube and counter. We saw in the detectors of radiation video what this looks like. And all we need to do to measure the background radiation is, without any other radioactive source or material there, is to turn on the Geiger-Müller tube and counter and start the stop clock, and then measure how many counts we get in a certain amount of time. And then by dividing the number of decays or the number of counts we get by the time in seconds, we can work out the activity. This would be the naturally occurring background radiation activity. It's all around us. There are natural and artificial types. Some of the natural types are radon gas in the air, from rocks and soil, and from cosmic rays from space. These are charged particles that travel through space, and these can produce nuclear radiation. Also the food and our bodies as well. Let's have a look at some artificial types. So this could be from nuclear weapons testing, or the fallout from nuclear bombs that went off at Hiroshima and Nagasaki. There's also radioactivity used for medical treatments, particularly radiotherapy is used for cancer treatments, but they're also used for looking at other imaging and to find out what's wrong with you within the body as well. Building materials can emit gamma radiation because they're made out of rocks. And the nuclear industry itself, we generate about 20% of our power in the UK from nuclear fission energy. So there's some contribution from that. Most of the contribution has come from where things have gone wrong. So you can think of the Fukushima problem in Japan when the tsunami caused the reactors to melt down, or you might have seen the Chernobyl films that are on. There's also been other issues over the last 50 years at Windscale, which is Chernobyl in the in the Lake District in England, and also there was a problem at 3 Mile Island in New Jersey in America as well. If we look at the radiation map of Britain, and this is a measure of background radiation. This unit here, millisieverts per year. We'll come on to what this means later on, but at the moment just look at where the red parts are. So you can see it's quite high in the southwest, Cornwall and Devon, right at the bottom of the UK, and there's some higher bits nearer to us in the Grampians near Aberdeen, and that's because the rocks there are granite rocks, and the granite rocks are much more radioactive and emit radon gas. Your body has evolved to cope with this, and you have ways of repairing yourself and not being damaged by the naturally occurring background radiation. It's only when the doses are particularly high that there can be particular problems that can occur. So, in conclusion, you have to know what background radiation is and to name some of the sources, man-made and artificial, of background radiation. And you should describe the experiment using the Geiger-Müller tube and counter and a stop clock, and how you would work out the activity of the background radiation.